So you stayed.
Actually, you showed up. That's step one. That's
okay.
a good start.
You stayed until the bitter end. Thanks so much for coming. I know we're the closing act at Spring One. I hope you've all had a great time here. My name's Graham Fisher. I work for the Raytheon company. I'm going to be talking about an engagement that we've done with Pivotal, and we'll be quite happy to do Q&A afterwards.
Yeah, my name's John Newell. I'm actually with Pivotal. I worked on the engagement that we're going to be talking about here.
Right, so this is who Raytheon is. While you read those words and go ooh-ah at all of the pictures, we're not the biggest defense and aerospace company out there. We've got a mere 67,000 people working for us. And on all 7 continents, we've got presence in Antarctica and everywhere else. We've got things deployed on land, on sea, in space, in air, under the sea. We make enormously complicated systems. Right? This isn't the sort of place where you find a shopping cart app. Right? Most of it is not. Most of it is sensitive, and it's just not the normal sort of systems that you get here. We're talking about at Spring One, but one of our visions is to make the world a safer place. And if you're wondering while you're looking at the pictures, well, how does that affect me? One of the systems that we build that's really important is the Joint Polar Satellite System. It monitors environmental conditions around the world. It monitors sea temperature and global warming. It monitors atmospheric stuff, land. It monitors things like wildfire plumes. So if you've got a wildfire going off out there, then we can send data in real time to fire departments and things like that, so they can actually start planning their mitigation activities. Another reason that we keep the world safe, if you flew here this week, I did, then Raytheon builds the air traffic control system for the FAA for all of the airports. So we build all of the radars and we build the air traffic control systems that the operators use. So we build stuff that affects everybody every day and in a meaningful way. So it's kind of fun to do it. And as I said, a lot of these systems are fairly sensitive. And there's an awful lot that we can't talk about. And I'm going to talk about a system that we can't talk about. And
we're going to talk about a system that we can't really talk about today.
Oh, that's true.
Yes.
Okay. Yeah, we are. The system that I've been working on for the last few years is an enormous distributed real-time system. It's in operational use. And to give you an idea of the scale of this, it's got about 6 million lines of code. It's taken about 10 years to develop. And it involves, we've got software running on Windows, on Linux. We've got Java, C++, Ada, Fortran, Python. We've got some funky chipsets in there with emulators for the test environment. We've got an awful lot of things going on. We have unclassified and classified software development, which adds another layer of complexity. Every environment that we deploy to is different, which adds yet another layer of complexity. We've got because of the size of the team, the project that we're working on, the teams are siloed, we've got subcontractors, and the net result of all of that is we have a really hard time building our software. We have a really hard time releasing it, and then when it's released, we have a really hard time deploying it. And it's not because we're using special stuff, it's just the overall complexity of it just says, this is hard. So we've been spending a ton of money and a ton of time investing in automation, and we've made enormous progress to speed up how we build and release and deploy things. And after all of that, we're still struggling. And the customer comes up, and Raytheon comes up and says, hey guys, you're making this way too hard on yourselves. Right? Just the complexity of all of this says, you're not going to win. So here's an option. Instead of building yourself a platform and deploying this here and that there, why not go and buy a platform? Right? And then everything becomes easy, right? Super. How many times have we heard that promise before? Just go buy this and you'll never need to work again. And so we say, okay, yeah, this sounds great. 10 years ago when the program started, the customer said, virtualization over my dead body. So all of our stuff's currently deployed on bare metal. But 10 years has changed the world. Virtualization has become a lot more acceptable now. The customer's changing, the company's changing, technology's changed. And so we're starting going down the lines, okay, maybe now's the right time to go and do it. So we've been building a relationship with Pivotal over the last few years. They've helped us meaningfully in quite a few programs now, you say?
Yeah.
To really deploy big, complicated systems like the ones I showed you in a meaningful way. So, but still, call us skeptical. We're not going to go jump all in here, right? We've tried that before. So instead, for the first time ever in a waterfall company.
Yeah, that's right. So instead of going all in and saying, hey, we're just going to change and move forward, Raytheon decided to conduct an experiment. Let's really prove out the viability of moving this complex system to a virtualized environment, aka the cloud. And if we go back to that last slide really quick, let me ask folks in the room, how many of you struggle with this type of stuff? Is it just Raytheon, or is everybody out there kind of struggling with it, right?
Oh, wait, they admit it.
Yeah, so the struggle is real, right? All right, so Raytheon decided to do an experiment, and they brought us in to help them work through that experiment. And how did that look? Well, they brought us in, and we came with an approach that said, hey, first thing we want to do is really understand your business, understand the complexity, and we want to work with you to come up with a strategy that will guide us through this experiment and meet the goals of the experiment, right? Prove the hypothesis. It will work or it won't. So we did a navigator first, what we call a navigator, where we come in and we look at those systems and tear them apart and figure out the right way to kind of do the work and figure out the right things to focus on. And then we did in a delivery phase where we actually engaged in the experiment based on the plan that we came up with. The goals of that experiment were really, like I said, assess feasibility and viability and reduce risk, right? Drive out any risk before they went and spent a bunch of money and a bunch of time trying to modernize this really complex system. And there were some constraints placed on us when we did this. We had to do it without any major re-architecting of the system, right? So understand that this system is really big, and it actually kind of has two facets. You have the core system itself, and then there's a simulation system that simulates all of the kind of external interactions that system might have with things that I can't talk about. And as part of the experiment, what we did is we chose to work on kind of doing some modernization and movement and virtualization of the simulated part of the system, right? It simulates all of the behaviors, and it has some other complexities that were ideally suited to helping drive out some of those, the viability things. Is it really viable to host C++ and Ada code and code that does this, some of these things in a virtualized environment? And it also provided an opportunity for the program to get their feet wet with Pivotal Platform and the cloud and that type of stuff, and learn kind of the Pivotal way of doing things. That's one of the things that we're really keen on, is changing the way the world creates software. So, during that navigator, we broke everything down, and the intent that we came up with is, hey, we want to replatform one of at least everything. So Java on Linux, C++ on Linux, Ada on Linux, C++ on Windows. And there were some wrinkles that we discovered during that navigator process. We realized, hey, there's some COTS involvement here. And it's not just Linux and Windows and Java and C++ and Ada. There's a few COTS elements, and those are kind of scary, and we really wanted to make sure that we included that stuff as part of this effort, not just cherry pick easy things.
Yeah, absolutely. I mean, our simulation system is a microcosm of the real system. It has all of the pain points. We have a hard time building it, releasing it, deploying it, etc. And it's got it has all of the same technology sort of diversity as our main system. So it's an ideal place to start, and it's smaller, but it's still big chunk of code, enormous chunk of code.
Yeah, in terms of scale here, talking 26 to 30 different components that make up this system, right? So it's not small.
Right. Right, okay, yay. So the program says, brilliant, go do an experiment. Yeah, right, okay, so where do we start? So it turns out, as big as our program is, we're always very pressured for schedule, and we're also pressured for bare metal resources. We can't just go stand up a platform any way we want to. We don't have, internally in our program, we don't have the skills to go stand up a platform. If we did with Kubernetes, we'd probably still be doing it right now. And so our IT organization has had a couple of successful journeys with Pivotal Platform, the PaaS piece of the Pivotal Platform in the past over the last year or so. And they volunteered, basically this is us calling a friend, and they volunteered to stand up PaaS and PKS, because we realized we need a lot of containerized workloads, in AWS GovCloud, which is the government's region of AWS, and they did it for us. So one of the, I think one of the big takeaways from doing an experiment is how quick can you get started? And for me as a software developer on the team, I kind of basically sat there and watched. And somebody else stood up the platform in a couple of weeks, and we did some network plumbing, and it's all good. And so the first proof of the experiment is, how quick can we get started? So yeah, that was pretty good.
Yeah, and you know what? To be fair, we didn't just sit there. While the platform was getting stood up by the IT folks over in AWS, we were doing the Navigator part of this engagement. So there was a lot of concurrent work going on. And from a platform perspective, we went from zero to hero pretty fast, right?
Yeah, yeah. Like I said, if we were setting this up from scratch, needing to train people on the program, yeah, we'd probably still be
doing it.
Okay, so this is the one slide with real words on it.
So let's talk about it. So during that Navigator, like I said, we broke down the work, and what we found was, hey, we've got some Linux on Java, and some of that was really suitable for PaaS. With minor changes, we could replatform it and host it on PaaS, and some of it really wasn't. So these are the 4 areas that we broke down, 4 different flavors of work that we had to do.
Right, and most of our system, even though it has most of the pieces of the system, even though it has totally different purposes in the simulator, boils down mostly into one of these things. So I'm going to we'll walk you through it left to right, starting with easy to interesting.
Less easy.
Interesting. So clearly, we're all at Spring 1. Most people here have heard about Spring Boot. I think it might take off. It might. And we found that some of our Java apps with fairly minimal refactoring are actually fairly cloud friendly. We could run them in PaaS by adopting a fair number of 12-factor app principles. We needed to deal with file system dependencies, manage logging. We needed to build a self-contained executable, rapid in Spring Boot, CF push, done. And I think the power of both Spring Boot and just make it so #1 is just so empowering. Okay, so that was our Java app. Next, we got 3 to go. So a load of our Java apps aren't that easy. Some of them have JNI. If you've got Java code that needs to interface to C++ code, you could probably do it in PaaS. I'm not sure it's worth the effort. It's fairly easy to go build a container with the JVM, with your C++ library dependencies, set the LD library path, spin it up, done. You can have a file system there. It was all fairly straightforward. There wasn't a huge amount of pain involved in doing that, and the developers loved it. Once you start building containers, it's not CF push anymore. You're using kube control, but it's still very easy to go deploy things. And
right, so that third area is where we started getting into maybe a little more esoteric workloads, right? So C++ applications and Ada applications. So those were actually not as difficult as we imagined. They were pretty much as easy as the Java apps to containerize. So containerization was really a good strategy there, and hosting them on, in PKS on Kubernetes was really a good choice. But there were a few wrinkles, right? We had some COTS interactions with those apps that made things more difficult. And we're going to get and talk a little bit about what those, difficult interactions were like, and maybe some of the solutions that we came up with here in a minute. And last, C++ on Windows.
So it turns out that we started off doing an experiment, and the idea of doing the experiment was to tackle the things that we thought were scary first. One of the things we thought was scary was all of the COTS dependencies that we've got. Some of them are Linux-based, and some of them are Windows-based, and we cannot change them. They're communications frameworks, simulations frameworks that are being provided to us. And it turns out that one of our Java apps that one of our C++ apps uses some COTS library that needs to talk to a license server, which is all great, right? When you're all on the same network, right? So, but what happens is the license server needs to talk back to the software that says, hey, I need to run here. And we're thinking, oh, right, I'm in Kubernetes. I'm in this nice little isolated network. And so all of a sudden, some of our COTS architecture shows up to be not cloud friendly. And you start exposing real problems really quickly when you start integrating these things. And it turned out that we got a license file and we could bake it into the container and start going. Fine, it'll run out in 29 days, and
which was fine for the experiment.
Fine for the experiment, but it really shows that you need to go take a good look at the architecture of all of the things that you don't own and you can't change, and maybe you need to go change them or replace them. So that was one thing that we needed to work out for the Linux-based stuff. Okay, saving the best for last. I'm sure you're all Windows fans. Half of this system's enormous, and about half of it is deployed on Windows. It's not .NET, it's predominantly C++, and it's not something you can just go port to Linux anytime soon. So what we really wanted to do was to use native Windows containers. Because I don't know if you've been to the talks. There was a talk yesterday about enterprise PKS for Windows. It was obviously a lot of money is being invested in Windows support for containers in general, Kubernetes, PKS. It's lagging Linux, but it's obviously coming up. And we really wanted to use Windows containers and run those in a cluster with all of our Linux stuff, and it would just run, right? Not so easy. We're using PKS 1.4, doesn't support Windows workloads. 1.5 does.
VMware.
On VMware. It doesn't support it in AWS, which is where we're doing our experiment. So while we could play around with containers a bit, we couldn't deploy anything into the platform. So what are we going to do? So we started dabbling around, and we discovered this tool called Wine, which is it's an abstraction layer that allows you to run Windows programs directly on Linux. And call me skeptical, I thought there was no way that this is going to work. So a lot of our C++ code we actually got running in Wine. And some of our C++ COTS actually needs a user interface when it runs. Even though it doesn't display something, it actually needs to connect to a display. And we learned after a while that we can set up a virtual frame buffer in a container, have the X window display for Wine point at the virtual frame buffer, have our C++ code running inside a Wine, displaying to somewhere in a container, hosted in a Linux, displaying to some virtual frame buffer sitting in a Linux container, running on Kubernetes inside a PKS on AWS, with Professor Plum in the library with a candlestick, right? So you can see the stack here, right? There's no way that we thought that this would actually work, but it actually is. I think that Wine is, if you don't have very many Windows workloads and you need to integrate some things in Kubernetes, I think Wine might actually be a really viable way of doing it. Like I said, our plan A is to go to Windows containers, and I think we'll keep dabbling with that when we can get it running on AWS.
Yep. Yeah, a few wrinkles that we ran into with Windows containers. So initially we were trying to use Windows 2016 containers. That was the first version of Windows containers that was going to be supported. For a number of reasons I can't necessarily talk about, but the COTS stuff wouldn't run there. Then 2019, which is a much more full-fledged, container citizen than 2016 was. We tried there, and ultimately because of the UI issues we had with the COTS, we couldn't really use 2019. It doesn't support
remote desktop
or any type of UI capability, at least not enough that would allow the COTS software to run there successfully. So that's another reason why we had to go with plan B, which was wine. And we actually, when we did that navigator, we thought this was, potentially going to be a problem, and we had wine in our back pocket from the very beginning when we first started doing the strategizing, right? And we just fell back to it when we got to reality of delivering and realized we weren't going to get there from here. Some things that we did during this engagement that were, for me, kind of really cool and profound. So remember, we're talking about this simulation system. Well, this simulation system is such that it needs to be able to dynamically create and run containers at user direction, right? So a user can create a simulation, say, I want to simulate this behavior, and then they want to connect real system components to those simulated components, right? So as part of this whole thing, we had to build the capability to dynamically create namespaces and pods and services and expose ports out of our cluster for interaction with these external systems. So learning things there. One, Kubernetes and PKS are super powerful. Two, we chose not to couple any of the system software directly to the Kubernetes API. So we exposed our own API that we allowed the other components of the system to interact with, namely the UI component that users can use to navigate and create simulations. But pretty cool stuff.
Yeah, I mean, it's interesting. I think most of the software that we're used to building is fairly static in nature. When you go deploy it, you've got a service over here, it talks to a service over there. Sure, you might scale them more or less, but it's fairly static on the whole. What we're doing here is a little bit differently. We are spinning up containers with having different purposes on the fly. So we're building, in fact, this is all done in PaaS. We've got a Java app running in PaaS that goes and creates pods, services, goes and creates a namespace to run them all, exposes all the ports, all at runtime. So it's pretty powerful if you're going to run something that is very, very dynamic, and it's pretty interesting that you can control this like between PaaS and PKS very well. Right? The networks all work fairly well. Right. So what do we get from all of this? So the biggest achievement is the program says, yay, we like what you did. And we're going to now go off and start looking at replatforming our real system based on what we've learned. So that's the number one thing. Hopefully we get to keep going. And number two thing is that all of those different technologies that are out there, the Java, the Windows, the C++, the Java, it all ends up in building blocks just like this. And then all of a sudden it's simpler to deal with. Right? So the complexity of our system is much reduced. It is a bit of a breath of fresh air when everything just like fits like that. We've given that we're running an experiment, we've tackled the hard bits first, and we've identified what we should be scared about. COTS architecture. I think we still don't know where Windows is going yet. We haven't tried it for real, right? But I think we've mitigated a lot of things that we were scared about before. We've worked around lots of it. We've got patterns to deal with it. We've got a lot of interest in the company because we're such a big program that people are watching what we do, and they're interested in the experiments that we're running. And then all of a sudden, a big program starts doing something like this. Everybody else gets interested, and then hopefully we'll get to, as a company as a whole, we'll accelerate modernizing, which is good. One of the things that everybody seems to be concerned about, which I think we've disproved, is everybody's scared about vendor lock-in. Hey, I'm going to go port my system to Pivotal Platform, and now I'm going to be embedded with Pivotal for the next 3 years, 30 years, whatever. And it turns out that we have 0 application hooks into the platform. Everything's based on Kubernetes. What we have got is value lock-in. Somebody else goes and builds this platform that we run our stuff on, and it's really easy. Right? So if we wanted to go do it ourselves, we'd be baking our own with Kubernetes, and so that would be really hard. But there's nothing in our application that says we're tied to the platform, and that's great, right? Loosely coupled, and on top of that, it means that because the Pivotal platform is itself infrastructure agnostic, we can go run it on VMware or AWS without affecting our application system, which is pretty empowering. Yeah.
So it is it's a cloud platform abstraction, right? There were some other side effects that happened during this engagement, though. Some really good things that happened, because like I said, when we come in and do an engagement, we're not just focused on replatforming applications, right? We come in and help enable the team to learn a different way of maybe doing things that might help them move faster and potentially produce higher quality code. So we worked with them on agile behaviors and XP and test-driven development, all of that. We also worked on their approach to building their software. So when we got in there and we started rooting around and started working on replatforming these apps, one of the things that we uncovered is a lot of the builds were interlocked and dependent on each other. So you'd go to build one component and it would actually go out and build 20 other components in order to do itself. And we said, hey, that's not a good approach. Let's break that apart. And we changed, pretty dramatically some of those components, build times from 2.5, 3 hours, right? Which you can't really iterate really fast if your build is taking that long, down to like 6 minutes. So that was a really cool side effect of the work that we did. Another cool side effect, some of those applications that we put onto paths, when we looked at them, we really said, hey, they're really, they're kind of like mini monoliths, and we broke some of them apart. Some of that was over JNI stuff, where we broke some of the functionality of an app out because it had JNI in, and we rehosted it as a Spring Boot service in PKS. But some of it was just around, hey, you know what, let's have single responsibilities for these services. And by doing that and bootifying them and leveraging the power of Spring and Spring Boot, we were able to reduce lines of code out of a couple of these apps by about 50%. So really big, cool side effect there. And then the other thing that came out, and one of the things that we're really big on is, recipes and cookbooks. And, here we have those 4 flavors of things, and we didn't just do one Java app on paths or one Java app, recontainerized in PKS, or one C++ app, we went through and established up front, hey, here's the patterns of how to do that. And then we went back and repeated and rinsed using those recipes that we created, and we did multiple of those apps following those recipes. And every time we did it, we got faster, and we shaved off a little bit of the rough edges, but clearly demonstrated the power of that approach and the power of the platforms.
Right.
So Graham, what's next?
So the truth is that we're still we're still not experts, and there's an awful lot about the platform that we haven't learned yet. One is it performant? Right? We haven't proven that we can get the same system performance that we do on bare metal. Now, am I scared about it? No, but we still need to prove it. The other thing is we run in a very sensitive environment, and we need to make sure that it is as secure as our current system, preferably more so. So we need to go and investigate that as well. That's from all of the disasstigs, secure sockets, all of those things we need to address. And so there's more work to do. But as I said, there's a lot of interest with the customer and our program to keep it going. So hopefully we'll do that. Great. How many minutes have we got? 2 minutes. Excellent. So you can laugh for this for 1 minute. Changing the subject just a little bit. So like I said, I work for Raytheon Company, and it's a really good company to work with. We have a really good value system. It's based on respect, integrity, ethics, and things like that. But over the years, I've observed, most of this is in jest, but I've observed this and more. And I think that there's an element of unconscious bias that's possible in all of us, right? Where this bad news always, send in the Brit, this bad news always comes better from you. And I always wonder is there some little thing here that advantages me because of my accent? And if that's the case, then does somebody lose out because of their accent, where they're from, their experience, all of those things, right? Who they are. And my ask to everybody else, all of you out here, is to treat everybody fairly, give everybody equal opportunities, and do the right thing to everybody else. So I think that's it.
Yeah, any questions? Comments? Gripes?
I think we're
complaints?
done. Thank you so much for coming.
Yeah, thank you for, oh wait, we have a question, yes.
Just wondering how much of that is Ada, and was that just legacy stuff, or is that actually developed Ada?
Yeah.
This is one of those things that we can't talk about too much.
So all of the code in our system is active development. Some of it's by subcontractors, some of it's in-house, and some of it's stuff that we have to run and don't have much say in what we're given.
Does that answer your question? Any other questions? Thank you guys, and I shouldn't say you guys. Thank you all for coming. Thank you very much.
Thanks all. Have a safe trip home.